Number 6. You, 60 kilograms, sit in the middle of the rough surface backseat of a car. The car rounds a 40-meter radius curve toward the right while moving at a constant speed of 10 meters per second. What must the coefficient of friction be between your pants and that of the car seat in order that you do not slip? So first I started by drawing my free body diagrams. I drew one for the car, which isn't really necessary for this problem, but I drew one anyway, and one for you or the person in the problem. And I drew my givens over here. You're given the mass of 60 kilograms, distance of 40 meters, tangential velocity of 10 meters per second, and we're looking for the coefficient of friction. So first, and this is really important to the problem, the friction force is equal to the centripetal force on you and the car. So I started off by using the equation for centripetal force, and I plugged in what we have, which is mass, velocity, and the radius, and I ended up getting 150 newtons for my centripetal force, and like we set up here, friction force equals centripetal force, so therefore the friction force is also 150 newtons. So next step, I went over here and I solved for the force of gravity of the person in the problem. I did 9.8 times 60 kilograms, which was a given, and I got a force of gravity of 588 newtons. And then I set up this equation. The net force on the y-axis is equal to the normal force minus the force of gravity, and that I ended up getting that the normal force is equal to the force of gravity in this situation. So I plugged both of the things that I solved for, the friction force and the normal force, into this equation. Force of friction equals mu times normal force. And I have force of friction. I solve for it. I also have normal force. Plug them in, and you get a coefficient of friction of 0.26, and that is the answer to the problem.